Hello, everyone. Thank you so much for taking the time to listen to my presentation on getting started with wolfSSL on the ESP32. Today, we're going to be discussing not only wolfSSL, but taking a look at a TLS example. So first, a little about me. I've always been passionate about embedded electronics. My first embedded project, I designed a 6502-based industrial controller for my senior project at Cal Poly. Today, I'm focused on embedded cryptography on the ESP32 devices at wolfSSL. Some of you may also know me by GoJimmyPie on social media. And so today we'll have a brief introduction to wolfSSL, how to get started, why choose wolfSSL, and where to find it. At the end, we'll have some time to answer some questions. Go ahead and ask the questions in chat as we go along. And so first, what is wolfSSL? Well, wolfSSL is a set of lightweight, high-performance, secure cryptographic libraries and applications related to open source internet security. It's all found on GitHub. So here are some of the many places where wolfSSL is already used. It's used to secure devices and communications in many different industries. It runs on nearly any device, from the tiniest embedded controller to massive cloud, VPN, and other computer systems. So as I mentioned, wolfSSL, it's a software library. It's designed to help developers implement secure communication in their applications. Think of it as a toolkit that helps apps and devices talk to each other safely over the internet or over other networks, ensuring that the data sent between them remains private and unaltered. At the core is wolfcrypt. This wolfcrypt library contains all the cryptographic algorithms that can be used by your applications and by the various other wolfSSL products on the ESP32 or other platforms. And so, although wolfcrypt libraries support nearly all possible protocols and algorithms, users of the ESP32 are likely interested in a tiny, secure connection with TLS to talk to some other computer, or perhaps some cloud provider with data acquired by the ESP32. One of the smallest footprints I've configured is on this Arduino Nano 33. I was able to get TLS working with less than 24K of RAM out of 32K total. And so, of course, you want standard TLS 1.3. That's ready to go. TLS 1.3 is the latest standard. No extra steps are needed, but perhaps you want to add post-quantum. That's available too. It's just a configuration setting. And later on, we'll talk much more about all the different configuration settings. The wolfSSL TLS 1.3 has been around much longer than Embed TLS, and it's considerably more robust. And so perhaps you're doing business in China. We support the SM ciphers, if you haven't heard of them. They're a suite of cryptographic algorithms that are widely used in China. wolfSSL added SM cipher support in 2023, and the core wolfSSL library can support the SM ciphers with the install script you see on the screen. So the SM ciphers are in the wolfSM repository, and you just run an install script pointed at your wolfSSL directory, make some configuration changes, and you're ready to go. And so how to get started? Well, like a lot of things, that depends. What are your requirements? Later on, we'll talk more about wolfSSL, but right now, I'd like to jump in and get started with some examples. I personally find seeing examples as a great way to get started. You can use wolfSSL on nearly any editor, nearly any platform. There are many options depending on your requirements. We'll start with what I think is the easiest method. So you can find the examples out on GitHub in the wolfSSL/wolfSSL repository. There's an IDE directory with many different IDEs. Inside there, you'll find the Espressif directory and the ESP-IDF, and under there are the examples you see on the screen here. So the core examples include a benchmark for performance check, just so how fast are the various algorithms, and you can fine-tune performance in the user settings. There's a test application, the wolfSSL_test is to make sure that all the algorithms are returning results as expected. There are also client and server TLS examples. If you want a no-fluff, bare-bones project, just getting started from scratch that includes compiling in wolfSSL, it's just a hello world, it prints a version. The one at the top there is called the template, and it's a great way to get started from just nothing and get going. And so when you use wolfSSL, you can also use wolfSSL as a component. We'll talk more about that later on. And so the bare bones template uses wolfSSL as a component. And here we see it as a local component in the project. And later on, we'll talk more about the other ways you can use wolfSSL. But this one specifically is a local component in your project. You'll see that it's in the components directory there. So all the examples on GitHub are ready to compile in place. Later on, we'll talk about different alternatives for installing wolfSSL, but here, the examples use the source code located in the repository. The CMake file, it actually searches parent directories looking for the source of wolfSSL. And in this case, it's just a few directories up. So you won't actually find the source code for wolfSSL in the examples. And you see the source files there, you see the little / slashes going up a few directories as to where the CMake file found it. Most importantly, the user settings are in the components wolfSSL directory in a file called user settings. And later on, we'll talk much more about the user settings, but that's probably the most important file for wolfSSL and setting the different options and configurations. And so first, we'll get started with an example here. And this is a sample TLS client. And you can see here that the first thing you do is you run the wolfSSL init. That gets all of the wolfSSL environment set up and ready to go. And a couple of lines down there, you see us opening your basic TCP socket. So next, you pick a TLS version, and you'll see some of the ones that are commented out there for if you want only TLS 1.2, only TLS 1.3. You can choose which ones you want to use here. Here you see a little bit of flexibility in which TLS version will be allowed upon a connection. There's an option here to ignore a peer check. But in this case, you'll see where the do peer check is set to true or 1. So a couple of lines down, we'll actually do a certificate compare with the peer. And so you see the set verify none is not being used here. So instead, a little farther down in the code, you'll see the steps to verify the peer with loading the client certificates. So there's a wolfSSL function here that loads the certificates. And these certificates are located, if you look at the user settings, it includes information on where those certificates actually are located. And you can, of course, plug in your own certificates. The next step down is we load the certificate authority. This is the public key certificate. This is the digital document that certifies the ownership of a public key, typically issued by a certificate authority. wolfSSL does have a sample also in the user settings. You can take a look at that. This is used to verify, the public key is used to verify the identity of a server or client, so when the connection is made. Here we see using wolfSSL to load the private key. So there's also a private key provided by wolfSSL in the examples. This is the secret key used in cryptographic operations. When paired with the public key, it's used to decrypt the data and used to create digital signatures. And so you see here some little error checking afterwards to make sure that everything was successful. So previously we talked about the peer verification, and so here you'll see the wolfSSL verify peer option. I hovered over the function there so we can see the parameters. So that last 0 is for a callback, and we're not setting a callback, but we are doing the peer verification here. And so next, we open a secure socket connection. We're going to open a TLS connection, and you see we new up a CTX object, and that's the wolfSSL context object. And you see if you have debug turned on, it'll also show you what ciphers are available. So it's grayed out here because I don't have debugging turned on, but it's a simple matter of going to your user settings and defining the debug wolfSSL and then turning debugging on. This example also has the SM ciphers disabled by default, but again, you can install the SM ciphers, go to your user settings, turn it on. The default user settings does include an example of how to turn on the Chinese, the ShangMi ciphers, and you'll see that you needed an explicit step here to set the key share. So once you've gone through that, all you need to do is attach wolfSSL to the TCP socket and connect. And so once you have the connection going, it's a simple matter of writing and reading data. So here you see an example of doing a wolfSSL write to the secure connection. So we have a buffer of len bytes long, and it'll send that out. And of course, to read data back, there's a wolfSSL read. It'll read data into your buffer there. And so here's an example. So I have the wolfSSL client that we were just looking at in PuTTY on the lower part of the screen there and in the COM port. And I have a client, the client is in PuTTY, and I have the server listening in WSL on Windows in the top part of the screen there. So I have those two overlaying on top of each other. And in this case, you'll also see that we have post-quantum. So the command line options allow you to enable post-quantum from command line there. And you'll see that we did a post-quantum key exchange with Kyber. This key exchange with the ESP32 was TLS version 1.3. You see the cipher suite that was involved. So the client, the ESP32 client, says hello message, and you see down below that the client, the server then responds with a I hear you for shizzle, and that's a typical common response for all the examples in wolfSSL. So it's important to note that all the wolfSSL TLS examples, they're all configured to be on port 11111. That's 5 ones. And so in my WSL example here, I needed to make sure that I had that port open on the Windows firewall. So when practicing with these examples, that's super important to make sure that your firewall is letting the packets go through. Wireshark can be super helpful in examining to make sure that, like, you see what's going on, but can't emphasize enough the importance of making sure that the firewall is allowing the port you're talking on and that you're talking on the port that you think you're talking on. So beyond the examples, we're going to talk more about the user settings in the CMake file. We mentioned before the user settings. This is where you customize wolfSSL for your specific use case. There are many, many different features to turn on and off. You probably don't want to turn on everything because it's big and bloated code. So you typically only want to turn on the features that you want. You can optimize it for performance or for size. It's all about the specific use case and what it is you want to configure. The other thing to look at, not as important, but you should probably be aware of it. It's the CMake list for wolfSSL. It's how the component is defined. And there's also an option in there to force a specific location of the source code if you want. So there's a variety of different ways to set the source code location, but it's important to know that the wolfSSL component in the examples, the source code is not there. It's shared source code in the repository, and as long as wolfSSL is in a parent directory of your project, you can go ahead and just use the default there. If you have a project that doesn't have wolfSSL in a parent directory, you can manually set it, or later on we'll also talk about managed components that kind of frees up that whole problem there of finding where the source code is. So here you see an example of that. It's called wolfSSL root, and it's near the top of the CMake file. You can just hard code a specific location if you want. We're also working on some features in a GitHub repository related to Espressif. We'll talk about that a little bit more later on. That's super exciting. There's an alternative way that we'll be adding a feature to set an alternate location for wolfSSL. But right now, it's the wolfSSL root is where the source code is located, and it's set automatically, again, if it's in one of the parent directories, or you can hard code it to a specific directory of your choosing. So if I were to present only one slide to talk about getting started with wolfSSL, it might be this one. For wolfSSL, it's all about the proper use of the settings, the user settings. And here we see an example. You need to make sure that globally defined, there's a macro called wolfSSL _user settings. That tells the environment that you're using wolfSSL. You see that we're including the wolfSSL wolfcrypt settings.h. It's super important that everywhere you use wolfSSL and any of the libraries, that the settings.h is included before any other file. Here I have an additional check just to make sure that the ESP-IDF has been properly detected. If not, unpredictable things could happen, but as long as you have that previous macro we talked about, we have that defined, and you include the settings.h, everything should be okay. You might want to also notice that I'm not explicitly including the user settings file. Okay, so the only thing you need to do is make sure you include settings.h before any other wolfSSL include files, and do not explicitly include the user settings. So the settings.h automatically pulls in the user settings and defines things as appropriate. I have another example here just in case you wanted to use any of the ESP32 cryptographic functions directly. It's in the ESP32-crypt header file, and you notice how it's below the settings.h, right? Again, super important, include the settings.h before any other wolfSSL include file, and do not include the user settings.h. And the user settings, that's where everything is configured for wolfSSL. And so next, continuing on how to get started, if you want a super easy way to just add wolfSSL to your existing project, you went to the components.espressif.com. It's the ESP registry, and there are examples there, and I have a screen shown on the screen here of how you can just copy that one line, and it'll add an entire component for wolfSSL to your project. And in this case, it actually does install it when you build your project. It actually does include all the source code. It downloads it from the ESP registry, in contrast to what we previously talked about of having source code located someplace else. So of course, as a managed component, you're probably not going to be wanting to make changes to that and contribute to upstream with GitHub. But this makes it super easy just to add wolfSSL to a project and get started. So if you don't have an existing project, but you still want to try managed components, there are existing examples. And so you'll see here, when you visit the website on the screen there, and really you can just go to, just search for Espressif ESP registry, and you can find the managed component registry. Just search for wolfSSL, and the last time I looked, it's really cool that wolfSSL is even listed on the home page. So you can just go there. Off on the right-hand side, on the right-hand side, there are some examples. And you can just click on that tab, and you'll see with just a few lines, you can get started. So you see, first I'm setting up the typical environment with export.sh. There's another icon that'll be on the screen that'll allow you to connect that second line, copy that to your clipboard, and you'll see that there's a idf.py create project from example. That'll create, in this case, the wolfSSL test. It'll create the entire application, including the managed component in a directory called wolfSSL test. All you do is you cd into that directory, and you build, flash, and monitor, and it should get going immediately for you. So yeah, the only catch there is make sure you probably want to specify a COM port. It'll look for the first COM port available. So if you have several, you might want to add the -P for the port, the COM port. So in summary, we talked about some of the different ways to get started. We have the ESP registry. It's by far the easiest way to get started with wolfSSL. You can also install wolfSSL either in your project, in the components directory as a local project, so components/wolfSSL, or you can install wolfSSL as part of the IDF. So you go to your install of the Espressif ESP-IDF, you'll find the components directory there, and you can copy or install wolfSSL there. So again, we talked about the CMake file for share code. That's one of the ways that you can point to wolfSSL. Oh, and the other thing is, yeah, we have VisualGDB project. So if you happen to use the VisualGDB extension, which is what I do all of my development with, the extension for Visual Studio, there's a VisualGDB directory. All you need to do is open up one of those projects and you're ready to go. So one of the more significant announcements earlier this year relates to the use of wolfSSL in the ESP-IDF. So in the previous slide, we talked about possibly manually installing wolfSSL as a component there. But recently, if you look at this issue out there, and it's in the Espressif repository and the ESP-IDF repository, issue 13966, it's basically the core issue for tracking all the improvements for wolfSSL integration with the ESP-IDF. And one of the first comments you'll see down there is it's been regarding licensing issues, and Ivan was super helpful in pointing out the ability to use wolfSSL as a local component installed in your application, but for the ESP-IDF to actually see that. And we're going to be adding support for everything in the ESP-IDF so that you can completely remove embed DTLS and use the commercial grade wolfSSL code instead. So previously we were talking about the configuration. Here's a summary of kind of where all the configuration happens. I have the expression there, with power comes complexity. There are many different settings. The user settings, by default, it has a good getting started, but there's documentation online for finding out where all the other user settings, what's possible. So you first start with the IDF menu config. It generates the SDK config file. You don't want to edit that manually because it gets auto-generated. All of the wolfSSL settings are in the user settings.h. Just for reference here, that you can see what goes on in the ESP32 crypt.h file. It's for reference. It's not meant for any changes to be made there. And finally, we talked about the settings.h. You can see where settings are adjusted there, but it's not recommended that you go into the settings.h and make any changes. The settings.h will typically change from release to release. We do accept pull requests, but for any project settings, you want to make sure that all of the settings that you make are in the user settings file in the components directory. So, and I also want to point out that the wolfSSL user settings applies to all wolfSSL products. So here you see some of the other related products. wolfSSL is a managed component. I also have wolf MQTT and wolfSSH as managed components. We have wolf TPM support for the ESP32. I don't yet have a managed component for that, but all those other products do not add a wolfSSL user settings file in the include directory there. There's only one user settings, and it's in the wolfSSL component. All of the other wolfSSL products will use the one user settings in the wolfSSL. So here's an example of what do you do with other components. Here I made a fun little project called SSH on a stick. It's the M5 stack, the M5 stick product from them. It's a Wi-Fi hotspot. You can SSH into that IP address, and you see here I have it connected to a UART. So this example is using wolfSSL and wolfSSH, as essentially a Wi-Fi SSH to UART example. And I probably should point out, like, not only can wolfSSL do TLS over TCP, but we can do TLS over pretty much any transport, Bluetooth, etc. So there's another getting started video that I presented not long ago. It's available on YouTube. Has a little bit different content. There you can find some details on JTAG debugging, more information on using the VisualGDB extension with Visual Studio, and more. So now that we know what wolfSSL is, well, why would we want to choose it? Well, it's by far the best tested cryptographic library out there. It's certified, widely used throughout the industry. There's a lot of companion products. So we talked previously about some of the different products. So it's all a family of similar and related products. We have a lot of partners, a thriving community. A lot of people really enjoy using wolfSSL, and we'll talk a little bit more about that in the upcoming slides. Yeah, previously we talked about the different products. You see them again here. Why choose wolfSSL? Because, well, when you want to do MQTT or SSH, or maybe even want to just use the same wolfSSL libraries that you're familiar with all the different environments you see across the bottom there. We have wrappers for different environments, for C#, for Java, for Python. You see that wolfSSL is used with curl. And so why would you choose wolfSSL? Well, for an ESP32 user, probably the most compelling reason is the really tiny footprint. Additionally, we talked about certifications. So it's FIPS certified. So that means basically the NIST has gone in, and if you have a project and you want it certified that it does exactly what you say it does, there's a certification process available for that. There's also DO 178. That's a certification typically used in aviation. We have 7x24 support. It's dual licensed. So you just ask yourself, so how important is security? Is the library easy to use? Does it have all the features I want? So you look, you compare wolfSSL to embed TLS. You see we have really consistent attention to open issues, much lower volume, the things that stay open. On the topic of TLS, note that TLS 1.3 is the latest. So embedded TLS 2 and 3, those are versions of their library, not the version of TLS. There's been some challenges recently with TLS. So curl, on the topic of curl, that's also a wolfSSL product in case you ever need commercial support. You can also use the libcurl option to generate some sample code to get started with curl. Another reason to use wolfSSL is we have an OpenSSL compatibility layer. So perhaps you already have a project using OpenSSL. It's super easy to get started with wolfSSL with our compatibility layer. So again, why choose? Well, it's a commercial grade serious software, open source, certified, up to 7x24 support. And so another reason to choose wolfSSL, you just ask yourself, are your cryptographic vulnerabilities handled promptly by professional dedicated staff engineers? So the wolfSSL vulnerabilities, when they're responsibly disclosed, they're typically fixed within 72 hours, and we will provide an update to our customers. And then shortly thereafter, we'll make an announcement that a vulnerability was discovered and fixed. We have dedicated engineers. You can get on the phone, talk directly to an engineer, automated continuous testing. And so more features. Before you choose an encryption library, be sure to check out all the features and capabilities, not only what you need today, but what you might need tomorrow. Here you see some of the additional hashing and cipher functions, for instance, available with wolfSSL. Again, we have the SM ciphers we talked about, post-quantum, the OpenSSL API compatibility. So it's used in many different industries. We keep somewhat of a low profile. We don't advertise who all of our customers are, But wolfSSL is used in many more places than people realize. There's billions of secured connections. We have 1,000 OEM customers. We have many resale partners. Here are some of our partners you see on the screen here. You might recognize some of these names. Even more partners, agencies, and more. Microsoft uses wolfSSL. You can find them. So it's a dual license. The code is clean rooms. This has all been written by scratch. There's no external dependencies, no prior baggage. It's completely open source, GPL v2 license. If you want a commercial license, that's also available. So where can you find wolfSSL? Of course, wolfSSL.com, out on GitHub, wolfSSL. In the Espressif components directory, components.espressif.com. We have an Arduino library. We have examples for them in the IDE directory. Arduino here getting started, you can just search for wolfSSL in the library. You can just go to the registry, search for wolfSSL. The ESP registry for managed components. You go out there, you search for wolfSSL. And that about wraps it up. Let me know if you have any questions. You can contact us at support.wolfSSL.com as well. Check out all the docs out at wolfSSL. Appreciate you all listening. Thanks so much.